Times whenever we're doing some differentiation, we have some problems that are going to present an issue for us. All right. Whenever we were going through, we could do them piece by piece, right? So when we did them piece by piece, if we wanted to differentiate y equals 2x plus 4, what's that going to be when you differentiate that? Y is 2. Y prime is 2. Okay? All you had to do is just do into each individual term. Okay? Then we did something like this. Y equals 4x times sine of x, for instance. That's just two terms multiplied by each other, right? Now, the chain rule is when we get something like this, maybe. Y equals 4x minus 2 quantity cubed. Okay? So it's really not, doesn't fall in any of those categories, does it? Everything's kind of clumped together. Looks like we could do a power rule, but what do you do? Do you distribute it through? You know, like it just kind of leaves us asking there questions there. That's where we have what's called the chain rule. So the chain rule says if y equals fu is differentiable function of u and u equals g of x is a differentiable function of x, then all this, and you can multiply them together. Basically, what you want to do is you want to turn this into essentially two functions. You kind of want to split it into parts. Okay, so you would want to take this thing inside here, kind of set it aside, and treat it as another function. Okay? Um, so we talked about decomposition of fractions before, right? Remember that in pre-calc? We did that. That was a little crazy at times. All we're going to do is we're going to rewrite some functions, and we're going to decompose composite functions. All right? So for instance here, if I have y equals 1 over x plus 1. Okay? I can treat the bottom of that fraction. I'm going to say that the bottom of that fraction is u, which is x plus 1. Okay? Then y equals fu, where I put u in for x in the function, would be y equals 1 over u. Okay, so then if I want y equals f and g of x, all I'd have to do essentially was plug u into y. Okay, I kind of broke it into parts. Again, if I have y equals the sine of 2x, this isn't multiplication, so there's no way we could differentiate this based on what we have right now. But I can say that u is 2x, so then the function is essentially the sine of u, and u is the 2x. Make sense what I'm doing so far? Just breaking it down into two easier pieces. I'm making this part really easy and kind of taking the messy stuff in and putting a u in its place, and that messy stuff's over here in the middle. You'll see here in a minute. And finally, we get one like this: y equals a square root. Well, right now, anytime we have a square root, to say it's the square root of x, we say it's x to the 1/2 power, right? If I have a whole bunch of stuff in there, what if I have 3x squared minus x plus 1, all within the root? And then I can raise it to that power. Then I just have parentheses with a 1/2. And again, what do I do with the parentheses? So I can rewrite this as u is all that junk on the inside. And then the overall function is now y equals the square root of u. So I just simplified the function. All right, I took that first thing and said, all right, I'm going to treat it like a square root. I'll set aside the junk. Second one, I'm going to treat this as a trig function, set aside the junk. First one, I'm going to treat it as just a basic fraction, set aside the junk. All right? So how does this help us? What does it do for the chain rule? Well, using the chain rule, we can take a function, we can break it into parts using this composition of functions, or the decompositions of them, and kind of do it in pieces. It's a lot easier to do it in pieces than to try to do it all in one go. All right? So this is kind of a practice thing. You just got to see them do them. All right, so y equals x squared plus 1 to the third. All right, so what this is saying, what the chain rule is telling us to do is if we differentiate the entire thing and then differentiate the junk, and then we just multiply the junk back in at the end, essentially. All right, so this here, our junk is going to be that stuff in parentheses there, right? So I'm going to call that u. So u equals x squared plus 1. All right. Now, if I do that, that now makes y u to the third. Okay. You good with? You guys still with me there? All I did was take this stuff and split it to over here. Okay. Now I'm going to differentiate both of these guys. So y prime, based with the u in there, is going to be what? 3u to the second, right? Now, what is u prime going to be? X squared plus 1 differentiates to 2x. Now, I bring it back in, and I'm going to have that y prime is going to be this times this. Okay, so I have 3. Now, what was my original value of u? X squared plus 1. So I plug that back in. All I did was just plug that u back in. Okay, multiply that by my u prime, which is 2x. All right, then I can simplify a little bit. I'm going to say that this is, actually I'm going to make this dy dx just for the sake of our notation. So I can go 3 times 2x. 3 times 2x is 6x, and then x squared plus 1 quantity squared. All right. So a lot of times what we call this is u substitution. Okay. So we stuck u in for the ugly stuff, then did that on its own, then plugged it back in. Okay. Just a little confused. You with me?
I don't understand how this is slick.
Oh, it's slick.
Yeah, this seems harder.
If you would have to do that problem, write it out 3 times, do the product rule twice, multiply everything back through. See what I mean?
Yeah.
That would be really ugly. So what this is doing is taking an ugly function or an ugly derivative, splitting it into 2 less ugly ones, and then bringing it back together.
I get what you're trying to do.
Uh-huh.
You're also just kind of gun with it. Like you're writing it down, but like I don't know. The you part, like going from the y, like the second y, I guess, like going from y to u,
Uh-huh.
and the third step.
All right. This is honestly, this is going to be one that's going to be a kind of practice.
Yeah.
So, but with that, again, I just found the ugly part. This is really the ugly part of this. Rewrote it as a power. Yeah, it is definitely a little more abstract. All right, because you're not just, it's not just straight step 1, step 2, step 3, step 4. You look and see where the ugly stuff is, where I can replace that ugly stuff with a u. Then I differentiate it with the u in it, and then I differentiate what I pulled out. Then plug back in and multiply. Okay, we'll do more. We're gonna do 1, 2, 3, 4, 5, 6 more examples today, if we have time. At minimum 3. Okay. All right. So what we just used there, where we just replaced the stuff that was in parentheses, it's called the general power rule. Okay. That's the most common way you're going to see u substitution is like that. or if you have maybe a radical or something like that, which we're going to see here in a problem or two. Usually it's for radicals or like quantity cubes, quantity squares is where you're going to apply that. So that's all we did. Took it, power rule with the U at the side, plug it back in, du tagged on the end. All right. So that's just another way to state it here with the general power rule. All right, so let's apply the general power rule. We're going to do another one, very, very similar. So we got f of x equals 3x minus 2x squared to the third power. Okay, what's my ugly stuff here? The inside. So that's going to be, this here is going to become my u. 3x minus 2x squared. Now I have to rewrite f of x with just a u. That's u to the third. With me there, Katie? Okay. All right, now let's find f prime of x here. What is the derivative of u to the third power? 3u squared, perfect. What is u prime? Yep, 3 minus 4x. Okay. Now, what we have to do then is bring back in our u and our u prime. All right. So u goes back in for u. So 3, u is 3x minus 2x squared. Okay. So that went back in there. And I multiply that by 3 minus 4x, which is my u. A lot of times you put in a du there as well. If you want to put that in as just a reminder, okay? It's not a bad thing to do. So we can go back here and put one in here as well. U. All right, which means the derivative of u. Okay? Now, is there anything easy we can do there for simplification? Not really, is there? You'd have to distribute and FOIL, and let's just not get into that. We can leave it like that. I'm all right with that. All right, let's try that one. Let's try it with a root. Go f of x equals the third root of x squared minus 1 quantity squared. Yep, that's it. Now, if it was just a single term inside, the squared and the third root's not horrible, right? Then I just make it 2/3. So let's take this here, make that my u. U is going to be x squared minus 1. Okay? So then now f of x, I'm going to rewrite as, I would just have a u inside there, right? But then it would be squared, then the third root. So that's the same as the 2/3 power, correct? Yep. All right, so we'll rewrite this as u to the 2/3 power. Still with me? Okay. Now, from there, let's find what f prime of x would be. So f prime of x would be 2/3 of or u to the 2/3 would be what? Negative 1/3. Yep. 2/3 minus 1 would be negative 1/3. All right, and then put that du on there. So remember to multiply. All right, now let's come over here to u. What's u prime going to be? Just 2x. Good. Okay? Bring it back together now for a final answer. So f prime of x is going to be 2/3, or u, which was x squared minus 1 to the negative 1/3, times du. Du is 2x. All right? Now, there's two things I don't like here. One, we have an easy simplification with our 2x and our 2/3. See that? And I don't like that power in the middle. So let's just take it back to the bottom. You all right with that? So here, this is going to be 2/3 times 2x. We're on the top, we're going to have 4x. On the bottom, we're going to have 3. Okay, and I'm just going to take a whole set of parentheses to the bottom. X squared minus 1 to the 1/3 power. I won't worry so much. I'm okay with fractional exponents. I just don't want negative exponents. All right, so we get 4x over 3, x squared minus 1 to the 1/3 power. Multiply the top number here, 2 times 2, x. That would be over 1. Okay. All right. Still with me, all right? All right. We're going to do 2 more. Okay. I'm going to do one more here. This one's going to be a quotient type 1. And then I'm not going to go on, but I am going to give you one to try. That work? All right. So just after this one, you will saw one with powers. You would have saw one with roots, and you would see one with a fraction. Okay? Give that last one copy down if I erase the bottom of it here. All right, so this one here, let's go, call it, switch up some letters here. Let's go g of t equals -7 over 2t minus 3 quantity squared. All right, this feels a little shaky off the start, doesn't it? Thinking fraction, negative in there. It's not prime. Gosh, you love that. All right, so I'm going to go ahead and rewrite this as a non-fraction one. So it'll be -7. You take this to the top to make it 2t minus 3 to the -2 power, right? Okay, so from there, let's do our u substitution. So where do you want to put u in at? Yeah, 2t minus 3. So u is going to be 2t minus 3. That leaves me with -7 u to the -2. Okay, now start differentiating. I'm going to have g prime of t is going to be, what would this guy, -7u to the -2, what's that going to be when I differentiate that? Good. 14u to the -3 du. All right. And then over here, we'll go to u prime. What's u prime going to be? Just 2. All right. So let's bring it back in. Bring everything back together. Substitute the u's back in. So g prime of t is going to be 14 times u, which is 2t minus 3 to the -3rd power, times du, which is 2. Okay. Everybody go with that? Now I'm going to do the multiplication, take the negative to the bottom. Okay. So I'm going to just simplify this. I'm at 14 times 2 is 28 over 2t minus 3 to the 3rd. There you go. There's the derivative of that guy. How's that feel? All right. I'm gonna give you two to try. Okay. I'm gonna flip to the next page, just for me. But there will be some stuff if you got side space somewhere. If you want a blank sheet of paper or whatever, don't matter. But I am gonna have like 3 problems for the simplifying differentials on the next page. All right. So here we go. 2 problems for you guys to try. 1, I'm gonna have f of x equals. Let's go with 3 x squared minus 4x to the second power. And 2, let's go with a of x equals 5 over. Okay, there you go. There's 2. On the first one, it's based around the power rule. All right, so we're going to rewrite this as 3u squared. All right, then u is going to be x squared minus 4x. Good so far. Okay, so then we'll apply our differentiation. F of x is going to be 6u du. Okay, then over here, u prime is going to be 2x minus 4. That work? Okay, now we'll take it, plug stuff back in. 6 times x squared minus 4x times 2x minus 4. And I think right there is about where we're stuck at. All right, so let's finish this guy. Maybe. I think we did finish it, didn't we? All right. I don't think there's nothing else we could do simple there to simplify this at all. So we stop right there. We're good to go. All right, second one. So we rewrite this guy. We have g. I don't need this, but g of x is going to be 5 times 3x minus 2 to the negative 2. Right? So then we write this as 5u to the negative 2, with u being 3x minus 2. Yeah? Okay. So g prime of x then is going to be negative 10u to the negative 3 du. U prime is going to be 3. Okay, bring it back over. So I have negative 10, 3x minus 2 to the negative 3 times 3. I'm going to do the simple simplifying here. I'm going to have 3 times negative 10, so I have negative 30 over, I'll take this guy back to the bottom, 3x minus 2, quantity cubed. How'd we do? How'd you do? 2 out of 2?
Why does it,
You find the
why does
derivative
it
of the
turn
derivative.
cube?
Why does it turn cube? Right here? Subtract 1.
Oh, yeah.
Yes, I found the derivative. This is the derivative of this guy.
I thought
It's the derivative of this guy. With me? Power goes out front. Subtract 1 from the power. How'd you do? You get the first one right. Second one, missed it. Bella?
I missed like the 10 part. Like I didn't.
Oh, okay. Gotcha.
I just plugged in.
How'd you do? Got them both?
I didn't make a negative.
Okay. All right, good deal. So we'll stop right there for today. I'm going to throw up a couple homework problems for you.